All right, folks, let's do this example 14. Example 14 says the position of an object on a coordinate axis at time t is given by this. What is the initial velocity of the object? Kind of an interesting question. First question for you, my friends, how do I find the velocity?
Derivative
Correct, you take the derivative. Derivative gives us the velocity. How do I find the initial velocity?
times equals 0.
Correct. Correct. Exactly. So when they ask us to find the initial velocity, they're really asking us to find S prime of 0, which is the same thing as V of 0. So I'm going to say t equal to 0 is the initial time. So let's do this question. So we know that if I take the derivative of the position function, that's going to give me the velocity function. So let's do that first, and then we'll plug in 0 later. I want to point out something actually here that I just wrote. Do you guys see that what I wrote here is kind of an error? I kind of want to make a point here. This function is saying my independent variable is t, but I put d dx because I'm used to working with x as the independent variable. This is incorrect. So this should be a t. I just want to bring that to your attention. Right now, you're like, why is this important? Like, who cares? But after 5a, you're going to take 5b. 5b is still calculus in one variable. But after you take 5b, you're going to take 5c. Not all of you, I understand, but some of you. And when you take 5c, you're going to have functions that have multiple inputs, not just one single input. So when you have a function with multiple inputs, then the variable that you're taking the derivative of is important. So taking the time to emphasize it now in case we take 5c together in the future. Okay. So let's take the derivative. Let's do this. So it's going to be the derivative of the top function, which is 1, times the bottom function, which is t squared plus 1, minus the derivative of the bottom function is 2t. We keep the top function, which is t, all divided by the bottom squared, which is t squared plus 1 quantity squared. I want to stop here and ask a question. And you can message me privately if you need to, but I kind of stopped writing the formula and I just started writing the answer. And I could put an extra step with what I'm doing. Is this too fast right now? Like, do I need to write an extra step? Like this 1 is the derivative of t. The derivative of t is 1. Yes, I can write an extra step for sure. Probably just should have as a default. So what we got to do is you got to take the derivative of the first thing times the second thing minus the derivative of the second thing times the first thing, all divided by the bottom squared. So if I were to write this using my notation, it's like this is the f prime, and this is the F. This is the G, this is G prime, and this is G squared. So our quotient rule is the derivative with respect to t this time of G prime G squared. This is F prime F and F. So this is our quotient rule. And then I just applied the quotient rule to each of the different pieces. No worries. You know, there's a few of you that reached out to me, and that's why I asked. I mean, I stopped because I wanted to ask if it was going too fast for you. And I didn't want you to feel like I'm just going to power through everything. So I hope this helps. I am going to simplify this while you guys are copying it down, just because this one, I could see it. It's going to simplify a little bit nicely. So this is going to give me t squared plus 1 minus 2t squared, all divided by t squared plus 1 quantity squared. And then this simplifies to 1 minus t squared divided by t squared plus 1 quantity squared. So on Wednesday, we are going to do the classwork together in class. So I actually ask you not to do the classwork. Feel free to start the homework if you want to, but the classwork, I want us to work on that together, just so I can see where you're at and I can see if there's any consistent errors that we need to fix. Okay. So we'll spend the first 45 minutes of class working on the classwork. All right, everyone. This is kind of a convenient place for me to stop. We still have 3 minutes left. Does anyone have any questions for me?
Oh yeah, I have a question about the quiz. So for our homework, some of the functions were like x to the 5th power or x to the 4th power. So I was wondering on the quiz. Oh, okay.
I don't even go x cubed.
Oh,
I just
okay.
do, Jason, it's on 2.1 and 2.2. And the 1.8 part is on the, is on Canvas. Yeah.
Professor, are we supposed to plug in the 0?
Oh, thank you. I totally forgot like what we were doing here. For sure, for sure. I've got 2 minutes. Woo! Okay. Let me slide this around like this. So this is our derivative. So we wanted v of 0, that's the initial velocity. So when we plug in 0, we're going to get 1 over 1 squared, which is equal to 1. How interesting. Did they give us units here? Oh, they didn't even give us units. Should I make up my units? Let me just squeeze it in here. The position in feet of an axis of an object on a coordinate axis at time t measured in minutes is given by that. So then if we did that, then our units would be feet per minute. Just to have some units in there, I don't want you to think units are not important.